4 meters. How fast, not how much distance.
I guess I don't see it.
Acceleration rate is 4 meters per second squared. Like, remember the video when the guy jumped out?
All right.
What is the acceleration rate of gravity? In meters. You don't remember?
No.
All right, 9.8 meters per second squared.
Oh, that's right.
And the U.S. customary is 32 feet per second squared. All right, so these are acceleration rates of gravity. So I'll give you acceleration rate of 4 meters per second. So if I drop this dry erase mark, after 1 second, it is going to be moving at 9.8 meters per second. After the second, it is going to 19.6 meters per second. After 3 seconds, it is going 29.4 meters per second. The acceleration rate is the pile on of speed every second. It's adding 9.8, then another 9.8, then another 9.8.
And you want to find out what's it going in the first second is what you're asking me, right?
No, I'm just asking you what, given an acceleration rate, what is happening every second?
That's the pile on.
Acceleration. So when I give you an acceleration rate of 4 meters per second, after 1 second, after 2 seconds, after 3 seconds, that's what the question is asking you. So if this is the acceleration rate, don't worry about the 9.8.
Right.
If your acceleration rate is 4 meters per second, after the first second, how fast are we traveling? If we start from rest.
4 meters per second.
Per second. After the second, how fast are we going?
8 meters per second.
8 meters per second. After the third second, how fast are we going?
12 meters per second.
12 meters per second. Now, what in the hell does 4 meters per second mean? What does that mean to you? Don't be afraid of making mistakes. You make all the mistakes you hear. I will correct you. Don't be scared. Spit it out. Tell me what you think. I need to know where your head's at. What does 4 meters per second mean to you?
It means that the object is moving at that speed, 4 meters per second.
So,
and then
okay, that's fine, but what does 4 meters per second mean?
That's the acceleration.
No, acceleration is 4 meters per second squared. Velocity. The velocity is 4 meters per second. Here, 8 meters per second. But what do we mean when we say 4 meters per second? What do we mean when we say 8 meters per second? What do we mean when we say 12 meters per second? And if you don't, just say, hey, yo, I don't know.
I don't know.
Okay, that means we're going to move 4 meters in this second. We're going to move 8 meters in this second. And we're going to move 12 meters in this second. That's what meters per second means. It is a rate of speed.
Okay, so for the first second, we're moving 4 meters per second. And in the second one, we're moving 8 meters per second.
In a second. And in the third second, we're moving?
Is 12 meters per second.
So how much distance do we cover?
In 3 seconds, we covered 24.
24, yes. Because in the first second, we moved 4 meters. In the second, we moved 8 meters. And in the third second, we moved 12 meters. So we moved a total of 24 meters in 3 seconds. That's what that question is saying.
Oh, I see. Okay.
But it's based on the acceleration rate. The acceleration rate says This is what you're going to pile on every second when we leave from rest. So at 0, we're not moving anywhere at the 0 second. When we get into the first second, we're moving 4 meters per second, which means we're going to move 4 meters. In the second second, we're at 8 meters per second. Per second, that's what that means. 8 meters per second. We're going to cover 8 meters in 1 second. Here, we're going to move 12 meters in 1 second. So in that 3 seconds of travel, we covered 24 meters.
I see.
Like if anything, you know, if it does not make sense, stop me, please. Now the fun question.
Oh man,
That's my evil laugh. It's like, ooh. All right. Because we may as well just recap and go over this since, you know,
Okay.
just to make sure that you're on speed.
that's fine.
Or up to speed. Read the question aloud, please.
An object falling from rest reaches a speed of blank feet per second or blank meters per second after falling 5 seconds. Ignore air resistance. At this
Okay.
time, it
We're not
is
gonna
falling
do-
blank.
We're not going to do 5 seconds. We are going to do 7 seconds. Because I did a video on this, on the 5 seconds. So, we want to know how fast and how far. And we want to know this in metric and US customary units. Okay, so let's define how fast first. So this is me and my bullhead up there. I drop an object. I went on
Okay.
top of the roof and I dropped my dry erase marker. All right. So we
Right.
want to know how fast this dry erase marker is falling after 7 seconds. How fast? Now, first, let's determine the units. In the metric system, how fast would something be falling? Assign a rate to it.
It'd be meters per second.
Very good. Meters per second. And how fast will be something be falling in US customary units?
Feet per second.
Feet per second, yes, sir. Now, why didn't you say meters per second squared or feet per second squared? I'm just asking.
Because
I'm just asking. I don't want no trouble with my brother. I'm just asking.
because it would be doubled, right?
No,
And
because you'll be talking
how-
about acceleration.
Oh, okay. That's right. You
And that
did say
only
that one
applies
time.
to, if we drop something at rest, we're only talking about the acceleration of gravity. So now that we've opened up that can of worms, what is the acceleration of gravity in metric and US customary units?
Metric is meters per second squared.
Okay, how many?
And
How many?
9.8 meters per second squared.
9.8. So in the metric system, 9.8 meters per second squared. What about in the US customary units?
32 feet per second squared.
32 feet per second squared. So when we say meters per second squared or feet per second squared, we're pertaining to the acceleration. What does the acceleration tell us?
How fast something is going in.
The pylon.
Oh, the pylons.
Write it down. Write it down.
So acceleration is telling us the pylon.
What's going to pile on every second? When I gave you acceleration, I said 4 meters per second squared. Boom, that's my acceleration. After 1 second, 4 meters per second squared. After 2 seconds, 8 meters per second squared. After the third second, 12 meters per second squared, which also determine how many feet we're going to cover in every second. So it's all connected. It's like,
So acceleration tells us the pylon of speed.
every
And-
second. So in metric, every second, 9.8 meters per second squared. In U.S. customary, every second, 32 feet per second squared. I go out on this building and I drop this dry erase marker. It's 1 second, 9.8. Second, 19.6. The third second, 29.4 meters per second. Now, when we're talking about meters per second, we're talking about velocity. We're talking about feet per second. We're talking about velocity. That's the result of the pylon of speed every second. But the
Could you repeat
acceleration,
that? I'm sorry.
I said, if I go and I drop this dry erase marker after
Right.
1 second, 9.8 meters per second, because that's the pylon. After the second, another 9.8 meters per second, which is 19.6 meters per second. Then after the third second, 29.4 meters per second.
Okay.
So that's when you key in and they say, hey, this is the acceleration rate. How fast is this thing going in 10 seconds? But in our case, 7 seconds. Now, what is the formula for velocity? Because that's how we're going to find out how fast. Do you remember? If you don't remember, say, I don't remember.
Velocity is
Oh.
velocity is distance divided by time.
Yes, in uniform motion. Is this uniform motion?
Nope.
So it does not apply in this case.
Oh, doesn't apply.
Velocity equals the acceleration times time in seconds.
Oh,
You have
Yeah, I
somewhere
think
in
I
your notes, V equals A times T. I know you got it because I told it to you. I don't
yes,
even know
you
if
did.
that-
I see it right here on the next page.
Okay, so I want to know how fast in U.S. customary units and metric units. We'll do metric units for my favorite. So velocity equals acceleration times time. How far will I go out on the building? I drop this dry erase marker. Now we know our formula. All we got to do is plug in the information. For metric, what is the acceleration of gravity?
9.8.
9.8 meters per second. And how much time in seconds are we concerned with?
7 seconds.
7 seconds. So, what do we need to do to calculate the velocity with these numbers?
We multiply them.
Yes, we do. Would you be so kind to do that for me?
Sure.
And practice makes perfect. You're going to be awesome at this.
$68.6.
68.6. 68.6 meters per
per
second
second.
is the velocity that this dry erase marker will be falling. If I went on the building and I'd let it go and said 1001, 1002, 1003, 1004, 1005, 1006, 1007. At the 7th second, it would be moving at 68.6 meters per second. That is a lot, isn't it?
Yeah.
It's moving fast, man. Okay, so that was metric units. Now we're gonna do U.S. customary units. What do we plug in for acceleration, sir?
32 feet per
32
second
feet per second times what?
times 7
Times
seconds.
7 seconds. Very good. What is my velocity?
224 feet per second.
224 feet per second. Good job. And why didn't you say feet per second squared?
Because that tells us the acceleration and we're
Okay,
asking
that
the
will refer to
velocity.
acceleration and we're asking for velocity. Good. I'm just throwing that. Now, what is the displacement formula?
It is.
Because the displacement formula is going to tell us how far something is falling in distance. So we go on a build, now let this dry erase marker go. In 7 seconds, how much distance does it cover? We're going to calculate that from the metric and U.S. customary units.
So displacement is half times the acceleration times time squared.
Very good, but is that the whole entire displacement formula? And
No.
why aren't you using the whole displacement formula?
Because the whole displacement formula only covers something that's already been moving, and
No, well, projectile motion is what I'm looking for.
Oh, projectile.
Because the whole displacement formula is displacement equals initial velocity times time plus 1/2 acceleration of gravity times time squared. Why are we using this whole thing?
Because the object is at rest.
The initial velocity is 0.
Right.
I'm not saying that you're not telling the truth. This is at rest if the initial velocity is 0.
Right.
But if we put 0 into this formula,
It's going to be 0.
It's going to 0 out. So we're just left, when we're dropping something from a platform, distance equals 1/2 AT squared. So since this is the example, we're using 1/2 AT squared. And then all we need to do is plug in the blanks, or fill in the blanks. So for metric system, or metric units, 1/2, what is the acceleration of gravity?
The acceleration for gravity is.
And use metric, I'm sorry if I didn't say metric.
9.8 meters per second.
Okay,
squared.
I'm going to put 9.8 there. Very good. And how much time are we concerned about?
7 seconds.
7 seconds. Squared. So notice I drew the formula. I wrote the formula out, and we're just stepping down, and we're just coming down. 1/2 A, 9.8 meters per second, times 7 seconds. So what are we going to do about this?
We are going to solve it.
Okay. What's the first part? What are we going to solve?
Figure out. Let's see. So 7 squared is 49.
We're going to square 7, multiply it by 9.8, and divide by 2.
Okay.
What do you get when you multiply 9.8 times 49? Hey, don't be cheating looking at my board neither.
Oh, sir.
No, I know. I see your head down. I see you working it out. I trust you, man.
For 80.2, 480.2.
I don't think that's it.
No.
I'm gonna
Right.
I'm gonna back you up. Hold on.
Let me
Hold
do it
that.
time.
What was your answer again?
I got 480.2.
That was correct. That was correct.
Did it? Okay.
I make a math mistake twice a year, man. Twice a year.
Only twice. Wow.
Yeah, that's my first time, man. I got all the way till Christmas. Hey,
It'll be a long year.
If you believe that, I got a bridge to sell you.
Oh man.
My Uncle Ben Franklin. 480.2. Now what do we do with the 480.2?
We divide it by 2.
Mm-hmm. And you should just eyeball that. What's half of 4?
2.
What's half of 8?
4.
What's half of 2?
0.5.
Half of 2 is 1.
Oh, that's right. Because we're dividing 1. Yeah.
So 240.1, 240.1 meters. That's a lot of meter sticks. Okay. 240.1 meters. Now, in U.S. customary units. Help me fill out my equation. 1/2, what is A?
Is 32.
And how much time?
7 seconds.
Okay. What's the first thing we're going to do?
We're gonna square 7, which is 49, and then multiply it by 32.
And then after we multiply by 32, what are we going to do?
Divide by 2.
You said that already, didn't you? Or no, never mind. Square the 7, multiply by 32, and then divide by 2. And just give me your number you come up with.
Okay.
Okay, he can't hear me now, but he's coming up with a number. So this is the area of kinematics. The mechanical comprehension portion of the SIFT test, which is the standard instrument for flight training, has been implementing a lot of physics concepts in the test. And if you're going to be a helicopter pilot, you're definitely going to need to know and be aware of.
I got 784 feet per second.
No, not feet per second, because I'm asking for displacement or distance. When you tell me feet per second, what are you giving me?
I'm only giving you the
distance?
velocity.
The velocity. Okay.
So it's going to be feet per second squared.
No, that would be acceleration.
Right.
Okay.
So it's not that.
So this is what I want you to write down. Acceleration units.
Okay.
Acceleration units would be in meters per second squared or feet per second squared. Let me know when you have that. Okay. The United States Army SIFT test is the standard instrument for flight training. So they've been implementing a lot of physics concepts in it, and that's why I'm covering it on the videos and stuff. So
okay,
I'm gonna Okay, distance. You would either get feet or meters. If we ask you how far has something traveled, or how far is it going to take, how many units of feet or meters is it going to take us to get there? That's distance. How fast? Meters per second squared or feet per second squared? Oh, no, meters per second or feet per second. You confusing me now, man. I'm only joking. And then, did we say time? Time, how long? So when I asked you, how far has this thing traveled? The only units you could give me are feet or meters, as it applies to our training.
So, for how long it's
Time.
Isn't it seconds?
Time in seconds, minutes, hours. Okay. So you need to be very specific because sometimes in the multiple choice tests, they'll give you numbers, but they'll give you the wrong units. And you go, oh, there's my number. And you'll be all over it and you'll be wrong. So what we were looking for is 784 feet. You said meters per second. Squared, I think, even. But
Yeah, I did. I said all of it, and I was wrong. So
whenever you solve a problem, you got to ask yourself, did I answer the question? Did I answer the question? Look at it. What are they asking for? Oh, how far did this thing fall in 7 seconds? You cannot give meters per second, feet per second squared. You can't give feet per second. If we want to know how far something has fallen, you can only give feet, period.
And velocity, the measurement was just
feet per second or meters per second. Feet per second or meters per second. And this will come. This is what, your second lesson in kinematics, so everything will come. You just practice.
Okay.
All right. All right. What is the difference between speed and velocity?
Speed is just going in one direction, and velocity is going in different directions. Oh.
You wrote this down in your notes. I remember I was there. If you invite me to a cookout, right?
Right.
Because you want your family to meet like this awesome tutor, this guy named Kino, right? And you say, okay, Kino, when you get there, come in the side gate to the back patio. That's where we're going to be grilling at. And I open up the gate, and your dog runs out. And I say, yo, your dog ran out of the gate when I walked in. Your dog ran at 10 meters per second. Is that going to help you find your dog?
No.
If I tell you that your dog ran 5 meters per second towards Mrs. Johnson's house, will that help you find your dog?
Yes.
Why? What's the difference?
Because you know the direction which the dog
what?
is running
The what?
at
Back
speed.
up. You know the what? Say it again. You were right. You guys spit it out. You said, I said 5
you
meters.
You know the direction.
You know the direction. The difference between velocity and speed is that velocity has direction. Velocity has a direction. When I say your dog left at 10 meters per second, okay, Kino, that does not help me. Which way? So velocity has direction, and we'll talk about that. Because it's kind of more to it than that, but that's like what I've gotten from debriefs. When they ask, oh, what's the difference between speed and velocity? Velocity has direction.
Okay.
All right. Oh, I'm tired. Or
Yeah.
my brain is. Okay. All right. Give me 1 second. Okay. So, yeah, that is my wrap up for this video. I got to continue on with my client. I'll see you guys later. If you guys need help with the standard instrument for flight training, please leave a comment below and I'll get back to you. But I'm Kino with STEM with Kino.com. Thanks for taking time out to watch. Please like and subscribe on your social media networks. And if you really, really like this video, go to my website and go to the support page to help support the channel. And click on any PayPal tile you wish. Take care. Go out. Okay.